welcome to our YouTube channel. We are working on a series of videos on creating scripts, job scripts on the HPC. And for this video, we'll be looking at a job script for OpenMP. So let's get right to it. In the previous video, we covered the C++ job script, and OpenMP job scripts are quite similar. So here I have a simple OpenMP program, simple hello world program, nothing too complicated. So the only difference from the OpenMP, C++ program is that now I have a pragma omp parallel here. So this is what creates the threads, and I have entity ID. So just to get the ID of the each thread, and then I'm printing from that thread. And here I have it's the same. The top portion is the same. The only difference is that now I have a new directory, because that is where my programs are saved, in this directory, OpenMP programs, and I have the executable here. Not much change. It's very similar to the C++ job script. If you haven't checked out that video, please watch it. And I have explained in detail what these functions are and how. Okay, let's get right to the live demo. So, okay. Yeah, I am in the directory OpenMP programs, and I am connected to a HPC param rudra. So right now I'm in the login node, because compiling the program takes place in the login node. The only thing that I am sending to the other nodes with C compiled program. So this is the program we are compiling. I have just added set num threads to 4, because I don't want 48 threads, 48 outputs from the program. And that's the job script. Pretty similar. So let's get to it. I can simply compile the program by doing G++, and I have to write OpenMP. So hello, is it a typo? Oh, hello underscore world. It is actually a typo. See, OpenMP.c omps that num threads. Let's see what it wants. Undefined reference to omp set num threads. Let's just remove it. I kept it there because I wanted to fix the number of threads, but oh, okay. I see what the problem is. The problem is not this. I haven't included the connector to OpenMP. So in this system that I'm working in, I need to add this connector. That's a connector to OpenMP. If I do that, now it's working fine. So without this, by default, the compiler is not connected to OpenMP. By adding this connector, compiler gets connected to OpenMP, and voila. So now the program is compiled. I have a.out for that. Yeah, it's there. So I can just do sbatch and OpenMP job script.sh. Let's check out the specifics of it once again. So instead of CPU, let's do standard. That's because I want to reduce the wait times, if any, in the case of specifying it. Okay, let's run the program. contains DOS line breaks, Unix line breaks. Okay, I think this is the issue. It's a Linux system, so if the file is saved in Windows DOS format, it may create problems. Now this job is submitted. I can check the job status by this command. SQ tells me what the SQ is basically a slurm command for finding out the job status, and Joby IUAC. That means I'm specifying I want to find out the jobs for this username. Let's check the output of it. Hello world from thread 0, thread 1, thread 3, thread 2. It's jumbled up not because of the system, it's jumbled up because some threads are faster than the other. Let's do one thing. Since we are on the topic, let's remove this, commit it out. Let's see what happens. Compile it again. I can submit the job script. Okay, so it's been assigned to RPCN 059 and it must have been finished by now. See, so I got 48 outputs. Why did I get 48 outputs? Because there were 48 threads on the 48 cores on the system. So it was by hardware it defined how many threads needs to be deployed. So let's get back to the job script, and that is actually pretty much it for the job script as well. You can mess around with it, change the number of tasks and tasks. So basically how many cores you need, you can change that. You can try changing the partition, set it to specified values like CPU or high memory, even GPU, because GPU nodes also have a CPU. You can test it out, but that is pretty much it for the explanation. So I'll be signing off with this. Thank you for watching.